In this question, we're going to use the empirical rule to answer the question. It says the Acme company manufactures widgets. The distribution of widget weights is a bell-shaped with a mean of 36 ounces and a standard deviation of 3 ounces. If it did not tell you to use the empirical rule, the keywords that triggered that you would use the empirical rule is telling you that it's a bell-shaped. It's approximately a bell-shaped, and they gave you the mean and standard deviation. So the moment you read those connecting facts, you want to think about the empirical rule. Okay, so what I like to do is with every word problem, I just like to write the important facts. So the important facts here was the mean is equal to 36 ounces and the standard deviation is equal to 3 ounces. So the notation here is representing a population mean and standard deviation. So I'm making that assumption that it's a population since they didn't tell us that it's a sample. And so what we want to do is understand what the empirical rule is. So it's a really good idea to make sure that you know how to derive parts of the empirical rule. So one of the first things that you should start off is by making a bell curve. The empirical rule is also known as the 68, 95, 99.7 rule. And what that's saying is that one standard deviation of your data is within 68%. I'm sorry, the other way around. 68% of your data is within one standard deviation of the mean. 95% of your data is within 2 standard deviations of the mean, and 99.7% of your data is within 3 standard deviations of the mean. So once you have your curve, what goes right in the middle is always going to be your mean. So your mean of 36 ounces will go right in the middle. So then you have your 1 standard deviation here, 2 standard deviations, and then 3. So how do you calculate the other numbers? Well, you need to use the standard deviation for that. So this direction is positive, so we keep adding the standard deviation to get these values here. So if I just keep adding plus 3 for my standard deviation, I fill in the rest of these numbers. And likewise, to go to the negative direction, I would take 36 minus 3, and then minus 3 again, and then minus 3 once more to fill in the rest of the numbers. So once we have this drawn, it makes it really easy for us to answer any type of question about the empirical rule. So 99.7% of widgets' weights lie between what and what? Well, again, 99.7%, I need to make sure I know the empirical rule. That's representing 3 standard deviations worth of data. So 3 standard deviations for this bell curve and for this data is going to be 27 to 45 ounces. So in the computer program, maybe it just wants you to type in the numbers 27 and 45, but if you were answering on paper, make sure you always include your units. Part B says, what percentage of the widget weights lie between 33 and 45 ounces? So for that, you want to go ahead and find and see if 33 and 45 ounces are on or are a part of your empirical rule with your standard deviations. So here's 33 and here's 45. So what percent is that? So it's really helpful to make sure that you have a good understanding of how to derive the empirical rule. Hopefully your instructor did that for you. If not, you can take a quick photo of this, and it kind of breaks down how we approximated all of these values here and how we calculated it. I work with 2 types of students, the students who, like me, I derived all of these, or the students that just quickly memorize these percentages along the way. Okay, if you do enough of these empirical problems, you'll probably memorize them as well. And so here we go. So 34% is, again, 68% of the data is right here. So divide that by 2, you got your 34%. This next corridor here is 13.5%. And then this next one, right, we're not including the tail. We want to stop at 45. So this last one is going to be 2.35%. So if you grab a calculator and you add up all those values, you will get 83.85%. The next question says, what percentage of the widget weights lie below 42%? So again, you want to see if it's on your axis here. So I see 42 and I want to add up all of those numbers below that. So you have 2 options. You could add up all of those numbers below that, or you could use the complement. So the complement tells you that a quick way to calculate this would be 100%, right? So underneath this bell curve represents 100% of your data. So 100% just minus these 2 sections right here. I think that'd be quicker to calculate it. So these 2 sections, I just have to put a parenthesis around it. If I'm using this on a calculator, I need to add these 2 up first, which is what the parentheses around it is telling you to do. Add these 2 up and then subtract it from 100, and we'll get 97.5%. Another thing you could do is you could just add up all of those values there. Oh, actually, this should not be highlighted, right? It's going to be it's going to be everything but those two values. So you would add up all of these values here to get the same exact answer that we would have arrived at. So either way, be comfortable with both methods, I guess, and just make sure that you know how to document your work if your instructor is asking you to show your work, and hope that helped.